Here we are going to find the sum of several expressions written using sigma notation. The first is the sum from k equals 1 through 7 of k squared. And so in this case, we're looking at the sequence a sub k, and notice that my notation has changed there. This is another way to write the sigma notation, with the k equals 1 to 7 written to the right of sigma. So you may see it in both forms. So in this case, our a sub k, the general term would be k squared. And we're asked to sum terms a1 through a7. And so this is 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared. And if you add up those numbers on a calculator, I think you'll find they come to 140. So the sum there is 140. In the second case, our a sub k equals 40. That means every term in the sequence is 40. And we are supposed to sum, and notice I used k there just out of habit, but the index we were given this time is j. So the general term a sub j would be 40, and we're supposed to sum a sub 4 through a sub 7. So since each term is 40, we are going to have a4 is 40, plus a5 is 40, plus a6 is 40, plus a7 is 40. So each of those terms is equal to 40. And so we have 4 times 40, or 160. In the next example, we are asked to write the sum without using sigma notation, but not to evaluate. So in this case, our sequence that is being summed is a sub k equals the square root of k. In other words, the general term of the sequence is the square root of k. And we are going to sum the 5th through the 9th term this time. And so it's going to be square root of 5 plus square root of 6 plus square root 7 plus square root 8 plus square root 9. That square root 9 can be replaced by 3. Square root 8 is since 8 is 4 times 2, we could write this as the square root of 4 times the square root of 2, or 2 square root 2. The other three do not simplify. In the next case, they've used I as the index. This is a little confusing because it doesn't mean that we're dealing with complex numbers. It just means that the index is I. So in this case, our sequence is A sub I with the general term 5I minus 1 over 5I plus 1. And it's going to be the 0th through the 4th term. Now this is a little bit unusual to start with the 0th term. It just means that's the first term in the sequence instead of being 1. And so in this case, we're going to have when I equals 0, we'll have negative 1 over 1. When I equals 1, we'll have 5 minus 1, or 4, in the numerator, and 5 plus 1, or 6, in the denominator. When I equals 2, we'll have 10 minus 1, or 9, over 10 plus 1, which is 11. When k equals 3, we'll have 15 plus 1, or 15 minus 1, I'm sorry, which is 14, over 15 plus 1, which is 16. And when I equals 4, we'll have 20 minus 1, which is 19, over 20 plus 1, which is 21. This could be simplified as minus 1 plus 2/3 plus 9/11 plus 7/8 plus 19 over 21. But they did not want us to evaluate that sum. And we have one more problem here. Sorry, while I clean up the marks that were left there. And it is the sum from k equals 5 to 8 of k times k plus 5. So this time, the general term of our sequence is k times k plus 5. And we're going to be adding the terms a sub 5 through a sub 8. And so this is going to equal. So a sub 5 would be 5 times 10. A sub 6 would be 6 times 11. A sub 7 would be 7 times 12. And a sub 8 would be 8 times 13. So this is A5, A6, A7, and A8. If we went one step towards simplifying, it would be 50 plus 66 plus 84 plus 104, I believe. But again, we were not supposed to evaluate.